Okay, now what is happening here? For this model, all the variables are co-integrated, right? That we have seen, that all the variables are co-integrated, that we have seen already. So all the variables are co-integrated. So we can run the we can run the, because all the variables are co-integrated, so we can run the uh, uh, vector error correction model, right? So what is the guideline? The guideline is, when all the variables are co-integrated, then we can run the vector error correction model. But if the variables are not co-integrated, we should run var model. So that is the normal guideline, right? If the variables are co-integrated, we can run the vector error correction model. But if the variables are not co-integrated, we should run only var model. So that is the guideline. So so we can run the error correction model right now. So I go to estimate var. Then I put the variables. Okay, first I put lending rate as a dependent variable, then GDP, and then M, money supply. So here LR is the dependent variable and GDP and M are independent variable. So what is our target? Our target is whether GDP and money supply can affect lending rate or not. That we want to check. So actually, what is our target? Our target is whether GDP and money supply can affect lending rate or not. So that is why the first variable is LR, lending rate, which is dependent variable, and other two are independent variable. And here I choose this one, vector error correction model, because the variables are co-integrated. And here I choose lag 2 because lag 2 has been advised by the lag selection criteria. So I am here using lag 2. Okay, now my model is set. That is LR is the dependent variable, right? And all are independent variable. And model is set. And I click here, the co-integrations. I click here. And here the number of co-integration is 1, right? It is already here. So it is 1. And suppose here I choose 3, option 3. And here I choose 1 because we have only one co-integration model, or we have only one error term. So that is why I am putting here 1. Okay, so the model is set. Now I can proceed with OK. The estimation has come up. You can see result has come up of the vector error correction model. You can see this is the co-integrated model, right? This is LR, right? and this is the error correction model. So that is the dependent variable. And here what is happening, the variables have automatically converted to first difference. So what is happening in the vector error correction model, the software actually what is doing the software is automatically converting all the variables into first difference. So you see from here, it is DLR, automatically converted to first difference. It is DGDP, the GDP converted to first difference automatically, and money supply converted to first difference automatically, right? And that the software does. If you always convert the variable into first difference, especially in VECM model. And here, so you can see we have taken two lag. So two lags are here: lag 1, lag 2, lag 1, lag 2, lag 1, lag 2, and the constant, right? Okay. But here actually, our target actually to use this first model. That means lending rate is the dependent variable, and and the others are all independent variable, right? Others are independent variable. And here, this is our target model. Model. It is the coefficient, error correction coefficient. This is called that is given here, mentioned here. You can see from here. This is second bracket is called standard error, and the third bracket is called T statistics, right? Second bracket is standard error, and the third bracket is T statistics, meaning that this one is the standard error and this is T statistics. Again, this is standard error, this is T statistics. Okay, actually what happens? It is the coefficient, right? Coefficient divided by standard error, you can get the T value. All the time it happens. Again, suppose this divided by this, you can get it. Again, coefficient divided by standard error, you can get the T value or T statistics. But the problem is that here is no P value. So there is no P value. There is no P value here. So now the question is that how to get the P value. That means probability value. How to get the P value. So that is the question comes up. Okay, how to get it, the P value. Okay, so what I do, I go to proc, then make system, then order by variable, right? I get order by variable, then I press it. So the result has come up. So you can see there are three models. This is the first model, this is the second model, and this is the third model, right? It is starting from C1 and end at C24. So there should be 24 coefficient in this whole system model, system equation model, and we call it, the whole things a system equation model. Okay, and out of these three, actually the first one is my target model. What is the first one? LR is the dependent variable. And what is C1? C1 actually is the coefficient of co-integrated model. It is the co-integrated model from here to here. That is the co-integrated model, right? And C1 is the coefficient of this co-integration. C1 is the coefficient of this co-integration model. And C2 is the coefficient of this variable. C3 is the coefficient of this variable. And what is C8? C8 is the constant of this model. So this is our whole model from here to here, right? Our whole model. Now this is our target model, and we want to estimate this model actually. And this model actually called error correction model. This model is called error correction model. Okay, so how to estimate this model? That is the question comes up. Okay, what I do, I select the whole model. I select the whole model and I copy it. I copy the model. I select model and copy the model. Then I go to, suppose I go to quick. I go to quick and I choose the estimate equation, right? I choose it, estimate equations, and I paste it. I paste it. So I paste the whole model. You can see from here, this model and this model is the same. I copy from here and paste it to estimate this model. So that is our target, to estimate it. Okay, then what I do, I click on the OK to estimate the model. I click OK. So the result has come up. You can see from here. This is the actually called error correction model, and here it is the dependent variable. So the whole model is the error correction model, and here the lending rate actually is the dependent variable. Lending rate is the dependent variable of this model, and all these are independent variables. And what is C1? C1 actually is the coefficient. C1 is the coefficient of error correction model until this, from here to here, right? From here to here, from here to here. C1 is the error is the coefficient of the error correction model, which is from here to here until this. So in this way you can see the whole model. Just see from here. And what is C8? C8 is the constant. You see from here, C8 is the constant of the model. Okay, and what is here is C1. This C1 means this one. This C1 means this is C1, right? This C1 means this C1. Okay. Now, what is the guideline? The guideline is that this C1, sorry, I've done a mistake. What is the guideline? The guideline is that this C1 should be significant and the coefficient of this C1 should be negative. The coefficient of this error correction term should be significant and also should be negative. And here we can see the coefficient of C1 is negative, right? So we are happy about it. And also the p-value is 0, meaning that it is significant, meaning that the error correction coefficient is significant and the coefficient is negative. So we are happy about it. Okay, now the question is that what does mean by this coefficient minus 1.46? What does it mean? It means that I'm writing here. It means that our means is coming up. I'm writing, sorry. So it means that, why is my model? Sorry, I lost. Okay, it means that, no, not this one. It has gone where? Okay, here, okay, here it come up. Okay, it means that I'm writing here. Okay, here the error correction term, that is C1, is how much? It is minus 1. It is minus 1.466600, meaning that actually this one is called error correction term, or this one is called speed of adjustment towards equilibrium. Speed of adjustment toward equilibrium, or I can say it speed of adjustment any disequilibrium towards long run equilibrium state. Okay, and here for our model, so speed of adjustment is how much? Speed of adjustment is actually 146%. The speed of adjustment is 146%, meaning that it is adjusting very fast. It is adjusting very fast. That means it is going towards equilibrium very fast, because the speed of adjustment is 146%. Okay, and so the speed of adjustment is 146%. So it is adjusting very fast towards long run equilibrium. Okay, so this part is done. And the second part is what about the other variables, such as what about this one? And here you can see, and other variables such as C2, C3, C4, C5, C6, and C7, they are all short run coefficient, not long run. They are all short run coefficient. That is C2, C3, C4, C5, C6, C7 and C8. They are short run coefficient, not long run. Okay, so suppose I check this one. This one C2, this is a C2 and C3, right? That means LR lag 1 and LR lag 2. Whether these two variables jointly can influence LR or not, that we can check. I am telling again, whether LR lag 1 and LR lag 2, these two short run coefficient, whether can influence the LR or not. So that we can check using wall statistics, that whether C2 and C3 jointly can influence LR or not. Okay, so that is wall statistics we can do. So how to check? I go to view, I go to coefficient diagnostic, then wall test, it is here, right? Wall test, it is here. So I put C2 equal to C3, right? Whether jointly they can influence the dependent variable or not. So I check OK. So it is the outcome, wall test. So I choose the you see here the chi-square value, right? I can check the chi-square value. It is how much? 1. The chi-square, the probability value is 1.67, right? So and what is our null hypothesis? It is the null hypothesis that C2 and C3 equal to 0, meaning that C2 and C3 jointly cannot influence the dependent variable. That is the null hypothesis. And the p-value is how much? 1.67%, meaning that less than 5%. So we can reject the null hypothesis and accept the alternative hypothesis, meaning that our these two variables such as C2 and C3, that means the variables with C2 and C3 jointly can influence the dependent variable, meaning that what is our variables? I can check from here. Our variables actually where is the model? Our model is which one? The model is comes up which one? Our model, that means where is our model comes up? Okay, not this one, not this one. So meaning that our model is which one? That is our model is which one? That means C2, C3. It is our original error correction model. So that means C2, C3, which is LR lag 1 and LR lag 2 jointly can affect our dependent variable. Okay, second example, suppose GDP lag 2 and GDP lag 1 and GDP lag 2, whether these two variables jointly can influence LR or not. That we can also check using wall statistics. And here our coefficient are two. One is C4 and one is C5, right? There are two coefficient. Whether these two variables jointly can influence LR or not. C4 and C5, okay? So I proceed, I go to view and coefficient diagnostic, then wall test. So I put C4 and C5, right? That is the null hypothesis that C4 and C5 is 0 jointly, which is this one, this and this, right? This and this. That is GDP1 and GDP2. I press OK. So this is the results, and this is the null hypothesis. This is the chi-square value, and this is the probability. The probability is less than 5%. So we can reject null hypothesis, accept alternative hypothesis, meaning that GDP lag 1 and GDP lag 2 can affect our dependent variable, that is lending rate, which is LR, and that is happening in the short run, right? So that is short run. Yes, they affect the dependent variable, right? So in the similar way, also we can check our other variables, that is whether money supply M1 and M2 whether can influence the LR or not, right? We can also check it using world statistics. So I go to view, then I go to the coefficient diagnostic, and I go to the world test, right? And C6 and C7, right? C6 and C7 equal to 0, right? So that is the null hypothesis, C6 and C7. Okay. Okay. Here you can see the wall test chi-square value. Here the probability is 11.86, meaning that more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that C6 and C7 is equal to 0, meaning that money supply lag 1 and money supply lag 2 have no influence on the lending rate, meaning that money supply lag 1 and money supply lag 2 jointly have no influence on the dependent variable, and that is LR, meaning that lending rate. So that is the short run decision, not long run decision. So what is our decision? The final decision is that GDP1 and GDP2 jointly can influence the dependent variable, but money supply cannot influence the dependent variable, which is LR in the short run. So that is the decision of this model.